Welcome to the AnyDESIGN tutorial 2 for cast steel. Open new project. Set the casting alley for cast steel, then select the mold type and size. Change the mold material to Furan sand. Open design target. Set the casting yield for 70%. Click recommended filling time and input the target weight. Open add material. Under cast steel, select SM45C. Then under cast iron, select FC250. Open Material Assign, then select Materials for Casting and Chill Material. Import the product. Select the product file to open it. The user may also change the working plane to however they wish and create their own user viewpoint to reference to the same viewpoint they have been using. Select Section Enable under the Tool tab. Observe and check the section plane. Under the Analysis tab, click Thickness Map. Use the scroll bar or click the positive and negative buttons to observe predicted shrinkage areas. Import the core. Select the core file to import it. Select Product and Core by dragging the mouse and press Link. Use Hotkey 4 to change the viewpoint. Confirm or change the mold size to 600 by 500 by 300. Set the drag height to 126.45 millimeters. Set the mold wall thickness, then observe. Select just the product and move the origin to 110 on x-axis. Select Product and Core and press Ctrl and left click to copy. Select the copied product and rotate 180 degrees to x-axis. Then set the origin to -110 on x-axis. Select the draft angle icon. Confirm the draft angle contour, then select parting line. Select parting line by work plane and click OK. Undo the draft angle icon and check the parting line. Select Tool, press Insert Image. Choose the image file and press Open. Then adjust the image size and opacity. The user can input parameters or manually drag the mouse to adjust the size to the product and the core. Under the Modeling tab, click Chill. Check Insert Chill of Primitive Shape and input the chill size. Check the created chill and move it with the mouse or input parameters. Set the origin to 110 on x-axis, 120 on y-axis, 20 on z-axis. Select Chill, then press Ctrl and left click to copy and set the origin of the copied chill to -110 on x-axis, -120 on y-axis, and 20 on z-axis. In part 2, we will begin modeling. First, click Pouring Path. Set the pouring path location. Then, enter the parameters to change the pouring path. Then click Pathline. Connect the pouring path with the path line. Input the parameters for cope pathline. Check by building into 3D build. Next, we will begin modeling the ingate. First, click Branch. Connect to the center of the path line. Select Flat Ingate and connect it to the branch and the product. Then input the parameters to change the shape of the ingate. Next, select Flat Ingate, press Ctrl and left click to drag and copy the flat ingate to the other product. Then, check the shape by building into 3D build. Next, we will model the riser with a sleeve. Click Sleeve, and in the database, select SQ-FM100A series FM100 A50 by 80. Use the mouse to move the riser and set the riser neck height. Then, select Sleeve, Ctrl and left click to drag and copy the riser. Check the shape by building into 3D build. To build the other sleeve, select Sleeve. Select SQ-FT500 T series and FT500 T60-90-90. Adjust the sleeve placement. Select another sleeve. Change the directional angle and move it to the desired location. Then check the shape by building into 3D build. In part 3, we will check the casting design. Under Analysis, click Health Check. Confirm the checklist below of the casting design. Then click Section Tracking. Select the runner cross-section. Then check all the sections. Click Runner Resizing. Input the gating ratio and the filling time and press Execute. Select the last step and press OK. Then click Execute. If the user owns any casting software, then pressing Execute will immediately export all the STL models into AnyPre. This will conclude part 3 of the tutorial 2. In part 4, we will use the cost analysis. Click Cost Analysis. Under Settings, the user can change the primary currency, secondary currency, and input the exchange rate and the date. In the design target, the user can set cost per product and estimated effect ratio. In the process capability, input the capability of molding and the working time. Average cost shows the major sections. And under material cost, we can see the subsections of materials that are used for calculating the cost. Under labor costs, we can see the subsections for labor costs. Under manufacturing overheads, we can see the subsections. In general expenses, we can see the general expenses that are used. The user can input all the values in order to create a profit and loss analysis. This concludes the tutorial 2.